We're going to walk through how to do a logistics regression analysis. We are going to use the beginning post-secondary students database. For our logistics regression, the dependent variable needs to be binary, and this database has variables in it that are binary, like degree attainment. So we're going to use this to take a look at logistics regression. Now, some of the key concepts of logistics regression is specifically designed to handle binary outcomes, like whether a student earned a degree or did not earn a degree. And one of its strengths is that it can handle different types of independent variables. Nominal variables like gender and race, ordinal variables like income brackets, and it can also handle continuous variables like age or family income. So this flexibility allows us to explore more complex relationships between variables and the outcomes. So while continuous variables can be used directly, sometimes it will be easier to interpret the results if you put the continuous variables into categories and create ordinal variables from them. So we're going to take a look at how to do that. So you have to be logged in to be able to have access to the data. So make sure you're logged in. If you time out, you still look logged in even though you're not. So launch this. So let's use this research question for this demonstration. Does the likelihood of earning a degree within 6 years differ based on students' family income levels? Before we dive into the logistic regression, it's helpful to look at the percent distribution. This allows us to get kind of a big picture understanding of how degree attainment within 6 years varies across different income categories. So we've chosen percent distribution, and now look for degree attainment. We want this to be the column variable because it's the dependent variable, and we need it to be binary. So they've got it in 3 different groups depending on where you got your degree or did not get a degree, and we need this to be binary. So we're going to create our own custom categories, and we're going to put these 2 together. Got a degree, and we don't care where. We'll rename that degree. And then to add the other category, you have to check this box first, and then you can add the category. You can't do it in the other order. This will be no degree. And then save it. So that is our column, and see it labels it here for you to show you the table that you're going to get. And family income, finances income. And let's take, this is the cohort of kids who started, they enrolled in college in 2011-12, fall 2011-12. So let's look at what their parents' income was when they first enrolled. And we want this to be the row variable. And now this is a continuous variable, but it is presenting it to us as categories. And the reason for that is because we're looking at percent distribution, and it's got to be in categories in order to do that statistic. So these are ordinal categories, and if we don't like the way they have divided these up, we can create our own custom ranges. There's a couple different reasons why we want to create our own custom ranges. Even if you like these ranges and you're okay with them, you want to create your own custom ranges if you need to use this variable again in a different analysis, and we do. We're going to use it in the logistic analysis. And if we don't save these ranges, it will be a continuous variable when we bring it into the logistic analysis. We're going to create custom ranges and then save it with a new name so that we have a variable we can use repeatedly. How do you decide which one your range is to be? You might already know because you wrote your research question a certain way for a given reason. Here, I don't know. So I took a screenshot of this and pasted it into ChatGPT and asked it to suggest categories based on the poverty level for a family of 4 in 2011-12. And here's what it came up with for the ranges. And I asked it to give me the reasoning so that I would understand how it got the ranges, and then it justifies it. So we're going to create our categories. We start, 100 is the lowest, so I think we have to start there. 100 to 30,000, because that was poverty level for a family of 4 in that year. And let's name them poverty. It'll help us interpret things later. Things are labeled and help us remember why we had categories the way we do. Now we save it. All right, so now we've got our variables, and before we run it, let's save our variables because we want to use them. We customize both of them. So here's how you do that. You click on the little save icon there. You have to check both boxes or they won't both be saved. Now, the name of this variable is misleading because it's not the degree attainment at the first institution. That was just one of the categories. So we're going to change the name of this to degree. And we're going to change the name of this to family income level. And then we want to save these, so you have to check the boxes and select a group. Well, I've got some groups from other things that I've done, but you can't save into a group that was created for different analyses. So I'm going to make a new group, and let's see, I'll call this example demonstration. You just name it whatever makes sense to name it, because that's where your variables are going to be. And to ever find them again, we don't need it right now, but I'm going to show you right now. This is a pull-down menu. And this says show all variables. This is really show original variables. The variables you create so you can use again, you have to do the pull-down menu, show my saved variables. And these are them. Now we can run them. So hit run, and this waits. You can read about that. Go ahead and take the default. And then this gives us the percent, degree, no degree, based on the income levels. So this just kind of gives you the big picture of what you're looking at. And you've got the pull-down menu here. You can look at confidence intervals, get the standard errors. The percentage distribution shows us how degree attainment within 6 years varies across income categories. For example, among the students in the poverty level category, only 27.2% earned a degree. In contrast, 79.5% of the students in the high income category earned a degree. So this clear pattern suggests that higher income is associated with higher rates of degree attainment. But while percentage distribution gives us a clear picture of group level differences, they don't tell us whether these differences are statistically significant. Additionally, the percent distributions don't account for other variables that might influence degree attainment, like age, race, gender. So to test statistical significance and control for other factors, we need a more advanced method like a logistics regression, which is what we're going to do. If you want to compare any two of these, though, you can do a t-test, which will allow you to do a pairwise comparison. So if you want to see if the poverty level students are statistically different from the high income, you can use this to calculate. And there's your t-value and there's your p-value, but you can only do pairwise here. But now we're going to do a logistics regression. And a logistics regression is a statistical method that's going to help us answer two key questions. Does family income significantly predict the likelihood of earning a degree in 6 years? And how does the likelihood of degree attainment change for students in different income categories relative to some baseline group? And we can choose whichever group we want for baseline, but I think it's going to make the most sense and be the easiest to interpret if we choose the poverty level as our baseline reference group. So choose logistic regression as the analysis type. And now we want to use those custom variables that we already created because we don't want to make them again. Remember, they're in the pull-down menu here, show my saved variables. And I saved them in that group. So you can either drag it in there or click on it. And now we have to choose a reference. And what we choose as a reference determines how we interpret the results. So we're going to choose degree. And then our family income level, it says it's continuous, but we've customized it and put it in levels. So that's our independent variable. And see, there's those categories we already created. And let's choose poverty level as our reference group. And so what the logistics regression will do is it will tell us how the odds change of getting a degree compared to the poverty level for the different levels. And let's run it. Take the weights. So it takes a minute, you have to wait, but here's the results. So let's start with interpreting the intercept. The intercept represents the baseline odds of earning a degree for the reference group. In our reference group were the students at the poverty level. So the odds ratio for the intercept is 37.4%. You turn that into a percent. And there's the t-value and the p-value, so you can see if it's statistically significant. Now, some of you are probably asking, why is the percent distribution of students in poverty who get a degree different from the odds ratio? The odds ratio is the probability of success over the probability of failure. So it's computed from the probability of success. You can see there in the formula. Now let's interpret the odds ratio for the other income categories, and these are the odds relative to the reference group. So these are their odds of earning a degree in 6 years relative to the students in poverty. So there for the lower middle income, their odds ratio is 1.43. So this means they have a 43% better odds of earning a degree than students in poverty. You could also say they are 1.43 times more likely to earn a degree. And here I'll just show you how to interpret each one of these. These tell you how to interpret those odds ratios. You can pause this and read it. And to write the interpretation, this is how you would write it.